Welcome back to my channel Math School. In today's video, let us solve question number 5 from part 6 to part 10 from exercise 11.4 chapter 11 Introduction to Trigonometry. In my previous videos, I have completed examples 1 to 15, exercises 11.1 to 11.3, questions 1 to 4 from the same chapter. If you have not watched these videos, questions 1 to 4 from the same exercise. If you have not watched these videos, do find the link in the description box below or click the I button above. So now quickly let us begin with the video. Question number 5 from exercise 11.4 chapter 11 Introduction to Trigonometry says, prove the following identities where angles involved are acute angles for which the expressions are defined. So this is the sixth part of this question number 5. In my previous video, I have solved the first part to fifth part, and in this video, I will be solving from sixth part to 10th part. So the question is, square root of 1 plus sin a divided by 1 minus sin a is equal to secant a plus tan a. So here we have to prove the left hand side is equal to the right hand side. So here let us consider the left hand side part and prove it to be equal to the right hand side part. So left hand side is given as square root of 1 plus sin a divided by 1 minus sin a. So to simplify this given equation, first we have to remove the square root term so that we can apply any identity or any formula so that we can bring in this form, that is secant a plus tan a. Now since we have to remove the square root term, so therefore we will rationalize here so that it becomes easier for us to remove the square root term. So what is rationalization? Rationalization is multiplying the denominator. Rationalizing means we have to multiply and divide with this denominator given. So here our denominator is 1 minus sin a. So we will multiply and divide by 1 minus sin a. 1 plus sin a divided by 1 minus sin a. So into the denominator is 1 minus sin a, so we are multiplying 1 minus sin a and also divide by the denominator 1 minus sin a. Okay, so by doing this, when we multiply and divide by the same value, the value of the actual equation given will not change. Okay, so that's why this is how we rationalize any given fraction, right? So now if you look in the numerator, it is of the form a plus b and a minus b. So to remove the square root term, since it is a fraction, we will apply the method of rationalization. So rationalization is a method where we will multiply and divide with the given denominator by just changing the sign in the denominator. Okay, so here we have 1 plus sin a divided by 1 minus sin a. So we will multiply and divide by changing this denominator sign. Since it is minus here, we will multiply and divide by 1 plus sin a. Okay, multiply and divide by 1 plus sin a. Okay, so this is how we rationalize any given fraction so that it becomes easier for us to remove the square root term. So here you can notice in the numerator we have 1 plus sin a into 1 plus sin a. So therefore this will become 1 plus sin a the whole square. This is 1 plus sin a the whole square. And in the denominator, if you see, it is of the form a minus b into a plus b. So we very well know the identity where a, if it is a plus b and a minus b, then the formula for this is a square minus b square. So we will apply here. So here our a value is 1 and b is sin a. So applying a square minus b square, so it will be 1 square minus sin square a. So this will become 1 plus sin a the whole square divided by 1 square is 1 minus sin square a. Now you can observe that 1 minus sin square is nothing but one of our identity. Here by using this first identity, that is cos square theta plus sin square theta equal to 1. So when we send the sin square theta to right hand side, we will get cos square theta is equal to 1 minus sin square theta. So here we can substitute the value of 1 minus sin square a as cos square a by using this identity, right? So we can write down square root of 1 plus sin square a. 1 plus sine A the whole square divided by cos square A. Here in numerator and denominator we have square and square value. This can also be rewritten as it is 1 plus sine A divided by cos A the whole square, right? So now you can observe that we have a square root term and inside we have a square term. So this square root and square term will get cancelled. So we will be left with 1 plus sine A divided by cos A. So since in the numerator we have a plus sign, so therefore we can also write this as 1 by cos A plus sine A by cos A, right? Because the denominator is common, that is cos A. So now what is 1 by cos A? 1 by cos A is equal to secant A, and sine A by cos A is equal to tan A. This we have learnt in our trigonometric ratio relationship, right? So we will apply here. So therefore we get 1 by cos A as secant A plus sine A by cos A as tan A, right? So this is the right hand side part which we have proved that left hand side is equal to the right hand side. So therefore you can write hence proof. Part 7 from question number 5 says sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So here we have to prove the left hand side as equal to right hand side. So let us consider the left hand side part which is given as sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta. So we have to prove this equal to tan theta, where tan theta is equal to what? Sin theta divided by cos theta. So we have to get this value. So here how do we get that? In the numerator you can observe we have sin theta minus 2 sin cube theta. So we can take sin common in the numerator. Similarly we can take cos common in the denominator. So we have sin theta, when we take out common you will be left here as 1 minus 2. Here we have sin cube theta. So when sin theta, when it comes out you will be left with sin square theta. Similarly in the denominator when we take cos theta outside as common, here we have 2 into cos square theta minus 1 will be left here. Here we have got outside the bracket sin theta divided by cos theta which is equal to tan theta. So we have obtained the right hand side value. But how do we remove this 1 minus 2 sin square theta divided by 2 cos square theta? Okay, so for this we can use our identity. That is the first identity, that is cos square theta plus sin square theta is equal to 1, or we can just find out the value of this cos square theta by sending the sin square theta right hand side. So cos square theta can be written as 1 minus sin square theta. So this we will substitute in our denominator here. So therefore you can write down sin theta into 1 minus 2 sin square theta divided by cos theta into 2. So 2 into cos square theta. So cos square theta value can be written as 1 minus sin square theta. So I'm writing in the brackets again because we have a 2 multiplication here. So 1 minus sin square theta minus 1. Now we can open the brackets and simplify further. So when you open the brackets, here the numerator will remain as it is, 1 minus 2 sin square theta divided by cos theta into 2 into 1 is 2 minus 2 sin square theta. Then after the brackets we have minus 1 again. Again you can observe that 2 minus 1 will give you 1 here. So we can write down sin theta, numerator is again same, 1 minus 2 sin square theta divided by cos theta. Here 2 minus 1 will be 1. Since 2 is a greater number, we will get plus 1 minus 2 sin square theta. So now you can observe that here in the brackets 1 minus 2 sin square theta is present in both numerator and denominator, which we can cancel out, and we will be just left with sin theta divided by cos theta. So what is sin theta divided by cos theta? That is nothing but tan theta. So therefore we obtain the right hand side value. So therefore you can write down left hand side is equal to the right hand side, and hence prove. So the 8th part of the question is given as sin A plus cosecant A the whole square plus cos A plus secant A the whole square is equal to 7 plus tan square A plus cot square A. So again we have to prove the left hand side is equal to right hand side. So here on the left hand side we have sine, cosecant, cos and secant values. So you must be wondering that we can change this cosecant and secant as 1 by sine and 1 by cos to bring it in terms of tan square A and cot square A. But instead of doing that, we can use the formula of A plus B the whole square and open the brackets on the left hand side. Since we are considering the left hand side part, we will write down the left hand side, which is given as sin A plus cosecant A the whole square plus cos A plus secant A the whole square. So here we will apply the formula of A plus B the whole square, which is written as A square plus 2AB plus B square. So let us apply here. So what is sin A plus cosecant A the whole square is sin square A plus cosecant square A plus 2 into sin A into cosecant A plus, now again we have here cos A plus secant A the whole square. Again we will apply the A plus B the whole square formula. So we will get cos square A plus secant square A plus 2AB. So 2 into A value is cos A into B is secant A. So here you can observe that we have sin square A and cos square A. So we can simplify this further by applying our trigonometric identities, where cos square theta plus sin square theta is equal to 1. So we are writing sin square A plus cos square A as equal to 1. Then again we have plus 2 sin A into cosecant A. So here cosecant A can be written as 1 by sin A, right? Okay. So here if we write 2 sin A into 1 by sin A and sin A will get cancelled and 2 will be left. Similarly, if you observe here, secant A can be written as 1 by cos A. So let us substitute those values. So here sin square A plus cos square A we have written as 1, plus we have cosecant square A plus 2 into sin A. Instead of cosecant A we will substitute 1 by sin A, plus then we have secant square A plus 2 into cos A into, instead of secant A we will write 1 by cos A again. Okay, so here sin A and sin A will get cancelled and cos A will get cancelled. So we will be left with 1 plus, now we have cosecant square A. Okay, so if you look in the trigonometric identities again, the value of cosecant square A can be written as cot square theta plus 1. So here we will write cot square A plus 1 instead of cosecant square A, plus here sin and sin will get cancelled, so 2 is left, plus again we have now secant square A, again applying the third trigonometric identity, where secant square theta is equal to 1 plus tan square theta. So instead of secant square A we are going to write 1 plus tan square A plus, now again here we have 2 because cos A and cos A is getting cancelled, right? So now we can add the digits, that is 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 1 is 5 and 5 plus 2 is 7. So we get 7 plus cot square A plus tan square A, right? So this is what is the right hand side part. So therefore we have obtained the right hand side part, right? So therefore you can write left hand side is equal to right hand side and hence prove. So here basically we are using the 3 trigonometric identities and the relationship between cosecant and sine and secant and cos to obtain the result. Part 9 of question number 5 says cosecant A minus sin A into secant A minus cos A is equal to 1 by tan A plus cot A. So here again we have to prove left hand side is equal to right hand side and they have given us a hint here to simplify left hand side and right hand side separately. So let us first begin with the left hand side part. So our left hand side is given by cosecant A minus sine A into secant A minus cos A. So here substitute cosecant A as equal to 1 by sine A and secant A as equal to 1 by cos A. As we know that cosecant A is equal to 1 by sine A and secant A is equal to 1 by cos A. So substituting, we will get cosecant A as 1 by sine A minus sine A into secant is again 1 by cos A minus cos A. Right? Now let us take the LCM. 1 by sine A minus sine A by 1. Here LCM will be what? Sine A. And in the numerator here we have 1 minus sine A into sine A will be sine square A into, again similarly here our LCM will be cos A. So 1 minus cos square A. Now we can use the identity which we know that from our first identity we have cos square theta plus sin square theta is equal to 1. What is the value of cos square theta? So cos square theta can be written as 1 minus sin square theta. Okay, and similarly what is 1 minus cos square theta? So sin square theta will be equal to 1 minus cos square theta. So here we can use the identity, instead of 1 minus sin square A we can write cos square A, and instead of 1 minus cos square A we can write sin square A. So 1 minus sin square A is what? Cos square A divided by A sin A into 1 minus cos square A is sin square A divided by cos A. Since multiplication sign in between, so we can cancel in the numerator cos A and denominator cos A. Similarly, numerator sin A can be cancelled with denominator sin A. So we will be left with here cos A into sin A. So further we cannot simplify, so we got the result as cos A and sin A. On the right hand side, if you observe, we have to obtain 1 by tan A plus cot A. So since in the hint they have given us that simplify both left hand side and right hand side, so since we have simplified the left hand side part, now let us simplify the right hand side part also to get this result, that is cos A into sin A. So now let us consider the right hand side part. So in some questions like these we have to simplify both left hand side and right hand side so that we get a common result. Right hand side part is given as 1 by tan A plus cot A. Now here again we will substitute the value of tan A and cot A in terms of sin and cos. So tan A can be written as sin A divided by cos A, right? And cot A can be written as cos A divided by sin A. We are doing this so that we get the result in the form of cos A and sin A. So doing so, we get 1 the whole divided by tan A is sin A divided by cos A plus cot A is cos A divided by sin A. Now here we can take the LCM in the denominator. So our LCM in the denominator will be what? Cos A into sin A. Cos A into sin A, and a numerator will be sin A into cos A into sin A. So cos A and cos A will get cancelled and we will be left with sin square A, plus similarly here sin A and sin A will get cancelled and we will be left with cos square A. Okay, so here again we have obtained sin square A plus cos square A, where we can use our first identity where cos square theta plus sin square theta is equal to 1. So here sin square A plus cos square A will be equal to 1. Okay, so we will get 1 divided by 1 the whole divided by cos A sin A. Now we can convert this division into multiplication by reciprocating the denominator. So numerator is 1, so into reciprocating the denominator we get cos A into sine A divided by sine square A plus cos square A. So here in the denominator we can apply again our identity, that is cos square theta plus sine square theta is equal to 1. So here sine square A plus cos square A will be equal to 1. Sine square A plus cos square A will be equal to 1. So we have cos A into sine A divided by 1. Anything divided by 1 is equal to cos A into sine A itself. So we have got the right hand side as also equal to cos A and sine A. So this is equal to what? Our left hand side part. So therefore you can write the right hand side is equal to our left hand side. So this is the last part of the question number 5, that is 1 plus tan square A divided by 1 plus cot square A equal to 1 minus tan A divided by 1 minus cot A the whole square is equal to tan square A. So we have to prove this first part equal to tan square A as well as we have to prove the second part equal to tan square A. So there are two parts in this question again, where we will prove first 1 plus tan square A by 1 plus cot square A equal to tan square A, and then again we will prove 1 minus tan A by 1 minus cot A the whole square equal to tan square A. So let us take the first part as left hand side. So that will be 1 plus tan square A divided by 1 plus cot square A. So here we can use our identities. We can use our trigonometric identities, where 1 plus tan square A is equal to secant square theta, 1 plus cot square theta is equal to cosecant square theta. Okay, so this will be easier for us by directly using the identity here. So you guys have to write down the identities which we are using. This will be 1 plus tan square theta is equal to secant square A divided by 1 plus cot square A will be cosecant square A. Now next we will write down the secant and cosecant in terms of sine and cos, right? So secant A can be written as 1 by cos A and cosecant A can be written as 1 by sine A. So we will do that. So secant square A is what? 1 by cos A the whole square divided by cosecant is 1 by sine A the whole square. So here removing the square term, so 1 square will be 1 divided by cos square A the whole divided by 1, again 1 square divided by sine square A when we remove the square from the brackets. Okay, so now let us change this division sign here into multiplication by reciprocating the denominator. So we get 1 by cos square A into reciprocating the denominator, we get sine square A divided by 1. After multiplication, 1 into sine square A we will get as sine square A divided by cos square A into 1 is cos square A. Now this can be rewritten as sine A by cos A the whole square. So what is sine A by cos A? Sine A by cos A will give you tan A. Okay, so we are going to substitute this identity. Tan A the whole square is nothing but tan square A, right? So this is the left hand side. So here we obtain the value as tan square A, which is in the right hand side part. Now similarly let us prove this 1 minus tan A by 1 minus cot A the whole square A is also equal to tan square A. So again we are considering the second part of our left hand side, where 1 minus tan A divided by 1 minus cot A the whole square. So here again, since we have to obtain the right hand side as equal to tan square A, so let us convert this cot also equal to tan. So cot A can be written as 1 by tan A, right? So let us substitute here instead of cot A as 1 by tan A. So we will get 1 minus tan A divided by 1 minus 1 by tan A. Okay, so in the denominator we have to take the LCM. So numerator is as it is, 1 minus tan A divided by, when you take the LCM as tan A, in the numerator you get tan A, that is tan A into 1 is tan A, minus 1, the whole square. Now let us convert this division into multiplication by reciprocating the denominator, right? So we get the numerator will remain as it is, as 1 minus tan A, into reciprocating the denominator we get tan A divided by tan A minus 1, the whole square. So here you can observe that in numerator we have 1 minus tan A and in denominator we have tan A minus 1. So to cancel these terms we have to take common this minus sign outside so that we can cancel out these terms. So taking out common, so when we take this minus outside, this tan A will become positive and 1 will become negative, into tan A divided by tan A minus 1. Okay, so now we can cancel this tan A minus 1 and tan A minus 1. So here you will be left with minus tan A the whole square. So minus into minus will become plus, squaring of minus will become plus, and tan A the whole square will become tan square A. Right, so again we have got the value on the right hand side as tan square A. So this is how we obtain the first part of the left hand side and the second part of the left hand side as equal to tan square A and tan square A. Right, so this is how we solve this question number 5. It is very important for you guys to practice all these given problems one by one, because only when you practice you will understand how to apply the trigonometric identities and the relationships to solve such kind of problems. So with that we complete the whole chapter, that is the introduction for trigonometry. Chapter number 12, some applications of trigonometry. So till then, do like my video, subscribe to my channel, and don't forget to hit the bell button below to get the latest updates of my videos, as I'll be completing the whole syllabus for class 10th SLC NCERT math. And also do watch the related videos shown on the screen. Thank you.